For almost 100 years, humanity has leaned on a single grand narrative to make sense of the universe. A framework so influential it shaped entire generations of scientists, rewrote textbooks, and claimed Nobel Prizes along the way. We call it the Lambda CDM model, and for decades it's functioned as our cosmic operating system. But what if that system is no longer up to date? What if the universe we thought we understood isn't the one we're actually inhabiting? Because right now, a telescope drifting 1,000,000 miles from Earth may have uncovered serious faults in the bedrock of modern cosmology. Not hairline fractures, structural ones. And the deeper it peers into space, the more disturbing the view becomes. That telescope is the James Webb Space Telescope, and it's revealing sights no one anticipated. Webb doesn't just see farther, it sees earlier. Every dim shimmer it records began its journey billions of years ago, long before Earth took shape, long before the sun ever burned. And when Webb turned its gaze toward the most ancient corners of the universe, regions so remote they should show the cosmos in its earliest, newborn state, it uncovered something startling. Instead of dim, fragile, primitive galaxies slowly assembling, Webb detected thousands of objects that simply shouldn't be there. They're too bright, too massive, too compact, too developed. Astronomers pored over the data and kept coming to the same conclusion. This doesn't make sense. By every established rule, the early universe should have been simple and quiet, a sparse expanse where matter was only beginning to clump together. But Webb is spotting intricate, organized structures where complexity should not yet be possible. For the first time in human history, we've looked beyond the so-called cosmic dark ages, the era just after the Big Bang when stars and galaxies were not supposed to exist at all. And instead of emptiness, Webb found order, motion, enormous, radiant objects already in place. Objects that seem far too mature for a universe only 13.8 billion years old. This isn't a glitch or a misread of the data. Independent teams around the world are seeing the same results. And some of the most respected physicists alive, yes, including Nobel Prize winners, are beginning to acknowledge something remarkable. The early universe may have been nothing like we imagined. A few are even entertaining a much more radical idea. What if the universe didn't begin the way we think it did? What if those distant objects aren't early galaxies at all? What if they belong to something else entirely? To understand why this is such a serious problem, we have to step back and look at the model itself. In the Lambda CDM framework, the cosmos is ruled by two unseen forces: cold dark matter and dark energy. Together, they dictate how galaxies take shape and how space itself stretches over time. In this picture, the first galaxies are expected to grow at a measured pace, slowly gathering material, slowly lighting up with stars. There simply shouldn't be enough time or enough raw matter for enormous galaxies to exist just a few 100 million years after the Big Bang. And yet, that's exactly what Webb is finding. Galaxies so massive and tightly packed that, on paper, they require more matter than the universe should have had at that moment. The math breaks down. The physics falls apart. The timeline no longer adds up. So what is Webb actually seeing? To find out, we have to step back and rethink how the universe itself really works. Back in 1929, Edwin Hubble uncovered something that completely reshaped our understanding of the cosmos. Galaxies aren't just sprinkled randomly across space, they're all drifting away from one another. Space itself is stretching. And here's the weird twist. This expansion doesn't have a center. No matter where you are in the universe, everything else appears to be racing away from you. Every observer sees themselves at the heart of the expansion. And the story gets even stranger. The universe isn't just expanding, it's speeding up. The more distant a galaxy is, the faster it's receding from us. Push far enough and you hit a limit where galaxies are moving away at the speed of light. This boundary is known as the Hubble sphere. Beyond it, galaxies appear to be retreating even faster than light. It sounds impossible, but it isn't. Einstein's speed limit still holds. It's not the galaxies breaking the rules, it's space itself, stretching and carrying them along. Because the universe keeps expanding, the Hubble sphere isn't fixed, it grows with time. That means light from certain galaxies that were once receding faster than light can still make it to us. Their photons are battling the expansion itself, riding a cosmic escalator that keeps stretching as they climb. But there is an ultimate limit, a final horizon. That horizon defines the observable universe, an immense bubble roughly 92 billion light-years wide. Anything inside it can, at least in theory, be observed. Anything beyond it is permanently out of reach. At the outer edge of this bubble is the oldest light we can see, the cosmic microwave background, a faint echo from when the universe was only 380,000 years old, a snapshot of the cosmos in its infancy. And past that boundary lies something we can never observe at all. The farthest galaxy we've ever observed, called Jade's GSZ 14-0, comes from a time when the universe was just about 290 million years old. We glimpse it as a cosmic newborn. But here's the catch. That galaxy is no longer visible today. It has already drifted beyond our observable horizon. Whatever it eventually became, whether it grew into a vast cluster or quietly faded from existence, we'll never find out. Its future is forever cut off from us. And that leads to a deeper realization. The observable universe isn't the entire universe. It's only our local view. Far beyond our horizon, whole regions of space exist that we will never see and can never affect. If the universe is truly infinite, and the evidence increasingly points that way, then it has always been infinite. The Big Bang didn't occur at a single spot. It happened everywhere at once. Matter didn't erupt from one point and spread outward. It emerged throughout all of space simultaneously. And the cosmic microwave background we detect in every direction is the lingering afterglow of that moment, arriving from all sides. That's the standard picture of the universe. But Webb may be pushing us to reconsider that picture. When astronomers pointed the telescope at the deepest reaches of space, they expected to watch the universe just beginning to figure itself out. Faint stars, small galaxies, the earliest and most fragile structures taking shape. What they saw instead was startling. Intense brightness, enormous objects blazing in a cosmos that should still have been mostly dark. A study in the Astrophysical Journal reported 87 candidate objects that may date to just 200 to 400 million years after the Big Bang. Even confirming a few of them would pose a serious challenge to modern cosmology. One of the researchers, Haojing Yan, summed it up plainly. If these objects truly exist, then our entire picture of how galaxies formed in the early universe is deeply flawed. And then came the most unsettling revelation. In ordinary galaxies, only about 10% of the available gas ever becomes stars. The rest lingers, a reserve for future generations of star formation. But Webb's observations hint that some of these primordial objects burned through everything. 100%. No remaining gas. No raw material left to sustain further growth. A scenario that shouldn't exist, at least not under any known laws of physics. Naturally, this has pushed scientists toward deeply uncomfortable questions. Are these structures even galaxies at all? Or are we witnessing an entirely new kind of cosmic entity, something that defies every category we've built so far? And if they are galaxies, the consequences are profound. It would suggest that our current understanding of the Big Bang is missing something fundamental, or is outright wrong. Perhaps the universe matured far more rapidly than our models permit. Perhaps gravity operates differently on the grandest scales. Or perhaps what we observe is just a fragment of a far larger, more complex reality. Some physicists are now toying with ideas that were once dismissed as fringe. Cyclic universes, earlier cosmic eras, even structures that may have existed before the Big Bang itself. One Nobel Prize-winning physicist has gone so far as to suggest that Webb might be hinting at something beyond our universe altogether. That sounds radical, But then again, so did the notion of an expanding universe, right up until it became undeniable. For now, there are no clear answers, only observations. And those observations are sending a powerful message. The universe is far from done surprising us. As the Webb telescope continues to look deeper into space and further back in time, one conclusion is becoming hard to ignore. The story we've been telling about the cosmos may be just the opening chapter. The universe just became a lot more interesting. Don't forget to like, share, subscribe, and let us know your thoughts in the comments.